Hey guys, so today's lesson is a super short one. We're going to quickly go over what bioaccumulation and biomagnification are. There's also some videos at the very end that you can watch if you would like to. I'm not going to include them in this video because last time I tried to do that, none of the sound came through. But they're not mandatory watching anyway. They're just for people who found this interesting and wanted like more examples or to just hear more about it. So yeah, feel free to watch those on YouTube if you would like. But other than that, just what I'm going to go over is all that's kind of mandatory from this lesson. So like I said, this is bioaccumulation and biomagnification. We're going to be going over what the difference between those are and what kind of impacts they have on different ecosystems. So bioaccumulation is the buildup of a toxic substance like a pesticide or different chemicals in an organism over time. Essentially, what happens is the organism is absorbing the toxins from the environment faster than its body can break down those toxins, and so the toxins build up in the tissues of the organism. Most bioaccumulation is harmful to the organism. In some cases, it can be used as a chemical defense for the organism, where the organism purposefully eats toxic things and stores those toxins in its tissues in a way that doesn't harm that organism, but will harm any predator that tries to eat it. However, that is very rare. Most of the time, the toxins that build up in the tissues of the organism are harmful to that organism. Because bioaccumulation is a buildup of toxins over time, species that live longer tend to have more potential for bioaccumulation and therefore have a greater risk of having a buildup of toxins in their system if their ecosystem or their environment has those toxins present. Biomagnification is also called biological magnification or bioamplification. They all mean the same thing. This is when a toxic substance builds up or becomes more concentrated in an organism the further up the food chain it is, or the higher its trophic level. This is because organisms that are higher in a food chain have to ingest more of their prey than their prey would have to ingest of their prey. Essentially, the higher level of a consumer or the higher level of a predator, the more it has to eat because it's only getting 10% of the energy available from the previous trophic level. So for instance, if we go back to like the example of a wolf and a rabbit, a wolf needs to eat more than one rabbit to survive. So if a rabbit has, 10 grams of toxin in its tissue, well, then the wolf is going to have to eat like, I don't know, 5 rabbits. And so it ends up with 50 grams of toxin in its tissues. So you have more toxins in the tissues of higher level predators just because they have to eat more things because they tend to be larger. Those toxic substances that are slow to break down tend to be built up more in the tissues because they can't be excreted quick enough from the body. And so this is just a diagram to kind of compare the difference between bioaccumulation and biomagnification. In bioaccumulation, we're looking at the same 3 fish in this example, but just over their lifetime. So when they're first born, they don't have any toxins in their system. The older they get, the more toxins that they have because they're just being exposed to the toxins longer, and so those toxins are building up in their tissues. In the second example, we're not looking at a change in time. We're looking at a change in trophic level. So organisms, sorry, it's windy out here, my hair keeps blowing in my mouth. Organisms that are lower trophic levels are going to have lower levels of contamination, whereas organisms that are higher trophic levels, like in this case the polar bear, are going to have higher levels of contamination. So one example of this that you do need to be familiar with is DDT, which is a pesticide that used to be really widely used to kill mosquitoes. Back in the 1940s, 50s, and 60s, this was used pretty much all over the world, including here in Canada. And then in the 1960s, bless me, in the 1960s, scientists showed that DDT was accumulating in the tissues of a lot of fish and birds, as well as some other wildlife, and it was declining those populations, especially birds of prey. So birds of prey are very high trophic levels. They're high level consumers. So fish, which would have toxins in them, would be eaten by smaller birds, and then those smaller birds would be eaten by the birds of prey. And so the birds of prey population in particular were really dropping off, things like eagles and stuff, and hawks. Essentially what was happening is the DDT was thinning their eggshells to the point that the eggs weren't incubating properly, and so they were having very few babies, if any at all. So because of that big decline in animals, in the 1970s, DDT was banned in most developed countries. So here in North America, DDT has been banned. There are still some developing countries in the world that use DDT. Usually it's countries that have really high death rates because of malaria. So malaria is a disease that's transmitted by mosquitoes. So if it comes down to, are we going to let humans die from malaria in order to protect the birds? Many of these governments have, rightly so, chosen to protect human life over bird life. But here in Canada and other places like in Europe and stuff, where malaria is not a big killer, it just wasn't worth it to kill the birds just so we don't have to deal with mosquitoes. So that was kind of the trade-off that was made. Another example of a chemical that is known for its bioaccumulation is mercury. Mercury is used in different industries and can contaminate water. It tends to build up in fish and animals that drink the water, and then of course also anything that is going to be eating those fish or those animals. And it can biomagnify that way. This is called Minamata disease. So Minamata disease is mercury poisoning that has affected humans, named for the first city that it was identified in Minamata, Japan. And essentially it causes like massive neurological issues. And we're talking like learning disabilities. It causes like fetal abnormalities. It causes paralysis, shaking, inability to walk, talk, all of that kind of stuff. So it's like a really, really horrible disease that is just caused by mercury toxicity, usually in people that eat a lot of fish that have been contaminated with mercury. And this actually happened in Northern Ontario, probably like a few decades ago now. And what happened is there was like a paper mill or a pulp mill or something like that that was dumping mercury into the water. And a First Nations community was fishing out of that water and eating the fish, and Minamata disease became very widespread in that community. Let me just pause while this plane flies over. Anyway, the water there is still contaminated. It'll take probably like over 100 years for the contamination to go away. The fish there can't be eaten, so a lot of people there have lost their main food supply. They've also lost one of their main sources of income, because taking people like on fishing tours and stuff like that was a really common source of income. And to this day, people who are born in that community tend to have birth defects related to mercury poisoning of their parents. So it is obviously a really horrible thing that affects humans as well as other wildlife. It was actually first identified in cats that couldn't walk and were like trying to stand and were too shaky and stuff. You may have also heard the phrase mad as a hatter, and that's because mercury poisoning can make people go crazy or mad. And back when like beaver pelt hats were like all the rage, mercury was used in the hat making process, and people who made hats, aka hatters, tended to go crazy because of their exposure to mercury. This is why mercury is not even used in thermometers or anything anymore, because it bioaccumulates in humans so easily. So try this question. Rate the following people from the person who is at the lowest risk of experiencing biomagnification to the one at the highest risk, and explain your rationale. So pause here, see if you can do that, and then come back to the answer. So the person who is a vegetarian is only eating things in the first trophic level. That makes them a primary consumer. So they're still fairly low in the trophic levels, which makes them at the lowest risk. Someone who is eating beef and potatoes would be a secondary consumer, because you would have the grass that is eaten by the beef, which is eaten by the human. So a third trophic level secondary consumer human would be still fairly low risk. Compare that to someone who is eating bear, which is itself a consumer. That makes the person at the very least a tertiary consumer, could be even higher than that. That does make them at a much higher risk in terms of biomagnification. So if you only eat plants, or you only eat herbivores, you're at a much lower risk than someone who eats other predators like carnivores and stuff like that. And these are the 2 videos that you are welcome to watch if you would like more information or more stories about this kind of stuff. Like I said, they are not mandatory viewing. Let me know if you have any questions.